For our next section of notes, guys, we're going to talk about 1-5, which is exploring angle pairs. When we talk about pairs, we're talking about two angles that we can use for certain names, all right? So our first one is we're going to talk about adjacent angles. Adjacent angles, or neighbor angles, as we will call them. Adjacent means beside or next to. So, two angles that share a common side and vertex and have no common interior point. So if you look down here at the picture below, you have angle 1 right here and angle 2 right here. They are right beside each other, but there's not one inside of the other. Same thing with 3 and 4. You have 3 here and you have 4 here. Don't get fooled on these because they're going to try to give you something that might look like here's one angle, and then they're going to draw another angle that looks like this. The reason that those are not adjacent is because if you look at it, the purple one is actually inside of the black angle, therefore it's not going to work out. That is not adjacent. That is the most common way that they're going to try to mess you up, all right? Next we're going to talk about vertical angles. Those are our scissor angles. These are two angles whose sides are opposite rays. A good example of this, guys, is they're always going to be across from each other. So if you look at angle 2 and angle 1 here, they're across from each other. And the key is you have to have two straight lines. You have one straight line here, but you also have one straight line here. And as long as you have two straight lines, that will give you the vertical angles. Also, 3 and 4 would be considered vertical angles. Now, this is going to come up later, but to go ahead and use a little common sense, you could look at angles 1 and 2 and tell me that they actually look equal. Same thing with 3 and 4. One thing that we are going to learn eventually is that the angles for vertical angles will always be congruent, all right? All right, next up, we have complementary angles. You should have heard this before this class, but complementary angles are two angles whose measures have a sum of 90 degrees. So if you look down here below, you have angle 1 and angle 2 equaling 90. Now, is there a number written in there? No. But you should know that this little red box right here tells us that they're telling us that it's a right angle. And if it's right angle, we know it's 90 degrees. Also, you could look at angle A and angle B here, and 47 plus 43 would equal 90, all right? I'm going to give you a little bit of a trick that's going to help you with this after we talk about supplementary angles, all right? So supplementary angles are like complementary angles, except these are two angles whose sum adds up to 180 degrees. So the difference is complementary is 90, supplementary is 180. Now, 3 and 4. This is one that a lot of people need to pay attention to because we talked about this in the last section. These two angles make a straight angle, right? If two angles form a straight line, they add up to 180, therefore they are supplementary angles. And then B and C, 137 plus 43 would equal 180. Now there's a big trick that's going to help you, and to do this I'm going to go back to both of these. So we know complementary starts with a C. So there's an easy number that you can make by just drawing one line, and that number is a 9, which tells you that it's 90 degrees, all right? For supplementary, you can make an easy number into an 8, which would tell you that it's 180 degrees. That's just a quick reference you can use. You don't have to if you remember the difference between complementary and supplementary. Some people would even say that a C is half of an S, therefore supplementary is double, or complementary is half of whatever supplementary would be. Things like that could help you. All right, it's up to you to use it. Use the diagram at the right. Is the statement true, and explain. It says angle BFD and angle CFD are adjacent angles. So if I draw angle BFD, it's that one, right? And then I draw angle CFD. Are those angles right beside each other? And the answer to that is no. And the reasoning behind that is because if you look at it, CFD is actually inside of angle BFD. They're not right next to each other because CFD is actually encompassed inside of it, okay? For our next one, it says angle AFB, which is this angle, and angle EFD, which is this angle, are they vertical? Yes or no? Now, to help us, I'm actually going to get rid of those lines so you can see this a little bit better. The key is it has to have two straight lines. So if you saw, you had this line, but then the other one was this. Is that a straight line? No. Therefore, they cannot be vertical angles if that does not form a straight line. Therefore, the answer to that one is also no. If both of those lines were straight, then they could have been, all right? Last one here. For angle AFE, we have this angle. And for angle BFC, we have this angle. They're asking if they are complementary. Well, complementary, if you remember, says they add up to 90 degrees. If I take 62 and add 28 to it, we do get 90 degrees. Therefore, yes, they are complementary because they add up to 90 degrees. All right? So for here you have A, B, and C. I want you to pause it. I want you guys to try these three, and then once you're done, go ahead and hit resume, and we'll go over it together. All right, so hopefully you were able to get these three. Let's go over it. For A, it says AFE. AFE is this angle, and CFD is this angle. They want to know, are they vertical? So again, I'm going to erase my lines to make this a little bit easier, but is this a straight line? Yes. Does that make a straight line? Yes. So are those vertical angles? The answer would be yes. All right. The next question asks us if these two angles are supplementary. The first angle being BFC, which is this angle. The second angle being DFE, which is this angle. So the question that they're asking is if I take 118 and I add 28 to it, would it equal 180? Well, clearly, hopefully you know by looking at it, if you take 118 and you add 28 to it, you would get 146. That is not 180, so the answer to that one would be no. And the reason why is they don't add up to 180. All right? For our last one here, they're going to talk about adjacent angles. We have BFD, which is this angle. And then we have AFB, which is this angle. Now, you'll notice the line that's shared is right here in the middle, right? That tells us that they are beside each other, which means they are adjacent. So your answer to that would be yes. So finding information from a diagram. There's certain things that you can conclude even though it's unmarked in the diagram. There's certain things that you can't. The first one that we're going to talk about are the things that you can conclude if it's not marked in the diagram. You can look at a picture and tell me if two angles are adjacent. What does that mean? Well, if I draw it over here, if I draw this angle here, and then I draw this angle here, are those angles adjacent? Yeah, they're beside each other. You can look at it and tell without anything being marked, all right? For the second one, angles are adjacent and supplementary. For that one, what it means is you've got two angles that are beside each other and add up to 180. So an example of that would be something like this. You have that one, then you have this one. Do they form a straight line? Yes, therefore they add up to 180. So that's what it means by adjacent and supplementary, all right? And then for our last thing that you can definitely conclude just by looking at it, if two angles are vertical. So if I draw, wrong button. If I draw this, and then from there we draw, make sure that it's a straight line here, make sure it's a straight line here, those two angles would be considered vertical because we have straight lines. You can look at a picture and you can tell me that from the get-go, right? So those are things that you can conclude. Now, things that you cannot conclude from an unmarked diagram. You cannot look at it and tell me if two segments are congruent or two angles. So if I draw you this angle, well, it might help if I was actually using the pen, wouldn't it? If I was draw this angle and this angle, you might say they look congruent, but do you know without a doubt in your mind? No, because you can't really tell that just by looking at it, okay? The next thing is angles are right angles. So you can see this and tell me you think it might be a right angle, but without knowing it for sure, you cannot conclude that. What you would need to conclude it is some kind of marking just like that. That would tell you it is. But if it's just like this, you cannot tell me that it is a right angle, okay? And last one, if angles are complementary. You can't look at two angles that don't have a measurement and tell me if they equal 90, okay? That's just kind of common sense. You got to know for sure. A lot of things you can't really assume in geometry, all right? So, let's make some conclusions from a diagram. what can you conclude from the information on the right? Well, the first thing that you should be able to conclude is due to markings. If you look at angle 1 and angle 2, they have these arcs, which tells us that angle 1 and angle 2 are congruent. So angle 1 is congruent to angle 2. That is done by marking. So that's kind of a free gimme problem there that you should be able to tell pretty easily. All right? What's something else you might know? Let's talk about vertical angles. Is there a set of vertical angles that you know are in here? Well, if you look, do we have a straight line here? Yes, we do. Do we have a straight line here? Yes, we do. So that gives us one set of vertical angles, which would be angle 3 and angle 5 are vertical angles. All right. Let's go on to the next one here. Something else that we can identify would be any pair of adjacent angles, all right? So there's a lot of different ones. We're only going to do a couple of examples here. So angle 1 and angle 2 are adjacent. You can go down the list. There's a lot more. You could do angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, angle 1 and angle 5. I'm not going to do every single one of them just because hopefully you get the idea of adjacent and you can play off of that pretty easily, okay? The next one is you can tell when two angles add up to 180, which two are supplementary. There's actually two sets here. The first one is if I take the measure of angle 3 plus the measure of angle 4, they would equal 180. How do I know that? Because if you see angle 3 and angle 4 would end up making a straight line, correct? There's also another set that actually does this, and that would be the measure of angle 4 plus the measure of angle 5 would equal 180, all right? Because if you see 4 and 5 here also make a straight line, all right? Go ahead and pause here. I want to see what you can conclude from the information below for A, B, C, and D. Give it a shot. There's a few of them in there that might be tricky. Pause here, and then we will get ready to go over those. All right, so hopefully you had a chance to do these. Are these four? You're trying to say if you can prove it. Now, you've got to be able without 100% or with 100% sure know that it's true. So look at A. Is TW congruent to WV, which is that? You can say yes without a doubt in your mind because do they have the tick marks representing it right here and right here? Yeah, so we know without a doubt in our mind that those two things are going to be congruent to each other, all right? The next one, for B, PW is congruent to WQ. This is the one that tricks most people. The problem is there anything saying that it's been split in half for sure? No, so you cannot actually prove it. You can think that it is, but in geometry, we like to have proof and evidence. Therefore, it's not going to work for us, all right? Next, we have that TWQ is a right angle. So TWQ is a right angle. Again, it looks like it might be, but you cannot tell us without a doubt in your mind that it is. Therefore, the answer to that one is still no. And last but not least, we have that TV bisects PQ. Now, in an earlier lesson, we did talk about bisects. Bisects means it cuts it in half. So you're saying that TV cuts PQ in half. Well, here's the problem. TV does not cut PQ in half. So the answer is no. If you think about it, would PQ cut TV in half? Yes, but TV does not necessarily cut PQ in half. And that goes back to this one right here, because that one wasn't congruent, or you can't verify that it was, it didn't work, all right? So you've got to be very careful with those. All right, next thing we're going to talk about is a linear pair. A linear pair, keyword there, if you see that it's underlined, is line. A pair of adjacent angles whose non-common sides are opposite rays, all right? The angles of a linear pair form a straight angle. So we've seen this a lot, now we're giving it an official name. It's two angles that form a straight line, we're calling it a linear pair, all right? It's For one, it's called a straight angle. For two of them put together, we call it a linear pair. You've seen this before. Which means if I take these two angles together, add them together, they're going to equal 180. All right? So let's use that for this one. The linear pair postulat says just that. If two angles form a linear pair, then they are supplementary because they make a straight line. They add up to 180. So for this one, it says angle KPL and JPL are a linear pair. If KPL equals 2x plus 24 and JPL equals 4x plus 36, what are the measures of angle KPL and JPL? Guys, for these problems, you need to learn to start drawing pictures, all right? So it says KPL and JPL form a linear pair. So what I would do is start by drawing a straight line and just drawing a line off of it like that. Doesn't matter what your picture looks like as long as it makes a straight line. And we're going to call this side KPL. All right? Then the other one is going to be JPL, which means I have to put a J out here, right? Now that we have that, well, let's write in the information that it gives us. KPL is 2x plus 24. And then it tells us that JPL is 4x plus 36. Now, if I want to go about solving this, I need to figure out what x is. And to figure out what x is, I need to know that the two pieces of this angle, since they form a linear pair, add up to 180. So I can say that 2x plus 24 plus 4x plus 36 equals 180. Now, our next step here is to go ahead and start combining our like terms, right? So what I need to do is take this 2x and add 4x to it, and it gives us a total of 6x. The next step we need to do is add 24 and 36 together. What that does is that gives us 60. Now that I have that, I can go ahead and say, what is 180 minus 60? And we would get that 6x equals 120. Once we have what 6x equals, we now need to go ahead and divide both sides by 6. When you divide 120 by 6, you get 20. All right? So now that we have our x, we need to figure out what our two pieces are. So we have KPL and JPL that we need to find. So let's find KPL first. The measure of angle KPL equals 2 times, in place of x, we're going to put 20, plus 24. When we put all of that in, well, 2 times 20 is 40. 40 plus 24 is 64. All right? Next one we need to find is JPL. So the measure of angle JPL is 4 times 20 plus 36. So if we find the measure of angle JPL, 4 times 20 is 80. 80 plus 36 would give us 116. Once we have that, we can verify that we're right by saying 64 plus 116 would add up to give us that 180 we're looking for. All right? Angle bisector. This is a ray that divides an angle into two congruent angles. So if you look at the picture below, the angle bisector would be considered this ray right here, ray AY. That is our angle bisector because it cuts the angle in half. So if I said that this is 40, then this side would also be 40, which means the whole thing would be 80. Whatever they give us for that, okay? So let's use that to solve here. It says AC, ray AC bisects angle DAB. If the measure of DAC equals 58, what's the measure of DAB? So the first thing we always want to do is draw a diagram. The first thing you need to draw is angle DAB. All right? Once you draw DAB, we could draw a ray down the center that bisects it, okay? And that's AC. Now, it gives us what each piece is. It tells us that DAC is 58. So, if I know that, they want us to find DAB. Well, guys, look at DAB. It's the entire thing. So, if I know that this piece is 58, then I know that this piece is 58. So, if I want to go ahead and figure out what the entire thing is, I add those together, and I get 116. So you got a got it problem here at the bottom. Number 4, I want you guys to draw a picture and go ahead and solve that one. Go ahead and do that now, pause it, and then resume once you're done. All right, so hopefully when you did this problem, your diagram started to look like this. Now, This one's a little bit different in the fact that they give us the measure of angle JKL, which is actually this entire angle right here. And I'll usually represent it by doing that arc out there to kind of represent that it's the whole thing. Just my way of doing it. You can figure out your best way of doing that. So what you need to do for this is if we're trying to find the measure of JKM, you need to realize that both of these pieces would be equal to each other, right? Because it was a bisector. So all I need to do is take that 72 and cut it in half. So if I take 72 and I cut it in half, I get that the measure of angle JKM equals 36 degrees. So that's our notes for this section. See you in class tomorrow. Good luck.